Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. First of all, I would like to thank everyone for joining our webinar series today. I hope everybody can sit back, relax and do enjoy our session. Ladies and gentlemen, before we begin our webinar, let us recite Kitab Al-Fatihah. Amin, amin, ya Rabbal Alamin. Hi, my name is Nora Ayu binti Ahmad Uze, lecturer from Faculty of Information Management, and I will be your moderator today. I'm very pleased to see you here and welcome all of you to the Faculty of Information Management webinar series 2021. For your information, this webinar is available through FB Live at facebook.com/UiTM And just a little reminder before we begin, if you have any question during the presentation, please feel free to type them into the chat box. I will bring them up during the Q&A session after the presentation finish. Ladies and gentlemen, this event is being organized by Center of New and Emerging Technology Research for Information Science, also known as CENTRIS, and supported by the Faculty of Information Management UiTM Puncak Perdana Campus. Today is your opportunity to listen to the webinar on learning analytics, and the topic of today's discussion is analytics of learning traces, role of course design and delivery modality. Now, moving along to our session, let me introduce our guest speaker, Dr. Vanessa Macha. Dr. Vanessa Macha is currently working as a lecturer and also holding a position of acting assistant dean, research and international affairs at the Faculty of Information Sciences, Prince of Songkla, University Patani Campus, Thailand. She has obtained her PhD from the School of Informatics, University of Edinburgh, United Kingdom. Her research interests revolve around learning analytics, learning strategies, self-regulated learning, technology-enhanced learning, and also technology-assisted learning. Without further ado, I would like to welcome the speaker to deliver the presentation. Well, Dr. Vanessa, the floor is yours.
Thank you, Dr. Ayu. So I am really glad to be here today, and thank you, Dr. Ayu, for the invitation, for having me here today. So as Dr. Ayu mentioned that my talk today, let me share my screen. Okay. Sorry, let me just swap my screen for a while. Okay, I hope you can see my screen clearly now. So as Dr. Ayu mentioned that my name is Vanessa Macha, and my talk today will be about learning analytic of learning traces, the role of course design and delivery modalities. I hope this talk will somehow beneficial to you, and I hope this talk won't be too technical, but let me know if I do speak fast or I do sounds too technical, or there is something you don't understand. You can leave a comment, and yeah, feel free to ask. Before we move on, I have one question for you. You may log into this wooclub.com/PSU Talk1. Please feel free to join us here. Here, let me show you here. Please feel free to join us here. I'm not sure whether you can see this clearly. Okay. Sorry. So I have one question for you here, if anyone is here. I have one question. Since we are all moving forward to the online learning, what did you find the most challenge you face when you participate in the online learning? Just feel free to answer it. And you don't need to log in to participate in this wooclub.com/PSU Talk 1. Okay, we got a few answers here. We got community and activity interaction. Yeah, what else? And we have focus on learning. Yes, I do find it's quite challenging. So I think let's look back into our talk here. Okay. Oh, sorry again. So as you answer inside the World Club, sometimes it's quite challenging to focus on the learning topic when you participate in online, and also it's quite challenging in terms of the community, the activities involved inside the online learning platform. All of this challenge because we suddenly have to shift to the online learning. Some of us are not ready for this. Some of us are not prepared to move to online. It's quite troublesome for both student and lecturer, because lecturer need to suddenly translate all the learning activities to somehow be able to support in the online learning. And these are a list of tools that are being used to support the online learning. Some of these tools might be familiar to you, some are new. You can have a look into this website, www.toptoolsforlearning.com. They kind of collect the data on the tools that are being used to support learning. And if you have a look into it, you might find some tools that may be useful to support your courses. So when we are using the online learning system or tools, which mean that students have a lot of digital footprint left behind. So the system kind of collect the data about how you interact with this kind of system, right? So as a result, lots of data is being collected. Lots of data is being collected. But then how can we make use of this data in order to support or in order to optimize the learning, in order to help the student learn better? This is where the learning analytics come into the role, into the play, sorry. So you might have heard of this term since you have a series of webinar in learning analytics, and you might have seen this official definition of learning analytics for several times now, right? But anyway, I'm going to have a look back into this definition once again for those who are not familiar with learning analytics. So learning analytics is boom, it started to come into the front row in 2011. During that time, the MOOCs, massive open online learning courses, has been well known and many participate in the MOOCs. And then the MOOC system itself collect a lot of data, and one of the founding father in learning analytics, George Siemens, highlight that we have a lot of data, but then we are not utilizing this data. So how can we make use of this data? So they introduced the terms learning analytics, and then they organized the learning analytics conferences in the first time at New York in 2011, and they give an official definition of learning analytics as a measurement, a collection and analysis and reporting of the data about learner, not just learner, but also the learning context. Why we are collecting, why we are analyzing the data about learner is because we want to understand. We want to understand how learner participate, how learner learn, what obstacle they faces when they learn online, and trying to find a way to optimize learning and the environment, try to find a way to better support the students. So Dragan Gashwick, one of the early researchers, one of the experts in the field of learning analytics, has come up with this model. They call it consolidated model, which is the models to explain the components of learning analytics. The learning analytics in 2011 began by using data science technique, machine learning algorithm to understand, to get insight into students' learning data, into the educational data. So they apply several of data science technique. For example, they apply sequence mining in order to design the dashboard, design the support system for the students. So this is the example of sequence mining and doing some clustering. And then they also apply process mining that give you a sequence of students' behavior from login to logout, starting what kind of action student doing and how often they are using these they are interact with the learning activities, for instance. And then this is another example of how we use the data science technique. This called network analysis, specifically this called epistemic network analysis. So another type of data mining technique that has been applied to analyze students' learning behavior. And of course, there are many more techniques has been used to analyze, to understand how students behave online, or some of them even try to predict the result of the students' learning. But then, in terms of technique to analyze the data is quite advanced, but some of the gap in learning analytic field is that many of the data scientists were neglect the use of theory. So this is your finding, what the educational theory say about this finding, whether it's aligned, whether it's confirmed, or even more. If this result is opposed the existing theory, this is one of the gap in learning analytics. So those who are interested in research in learning analytics, this is one of the gaps that you might need to look into. Another challenge when you participate in online learning is the tactic and strategy. Whether or not you participate in online learning or face-to-face or flipped classroom or blended learning tactics and strategies are the essential skills that one need to obtain in order to doing well in the courses. But then again, the research found that students hardly receive feedback on how to select the appropriate learning tactic and strategies. This is one of the gaps highlighted in the research, in the educational research. Why? Because providing the feedback is quite challenging task, especially when we learn online during the online task, because sometimes when we open the course online, for instance, in my class, most of the students will just turn off the camera. So I just see the name tag of the students. And it becomes very difficult for me to observe, or it's impossible for me to observe how the student learn, whether they understand the contents, unless I give them a quiz, right? So how to provide the feedback when you cannot observe your own student? That is very challenging task. And more, then the learning analytics come into play because the data has been collected how the student participate in online learning, isn't it? So learning analytics has potential to support the feedback provision. But then another challenge arises. So what kind of method we can use to detect the learning tactic and strategies? This is the focus of the talk today, about the detection methods. to extract the learning tactic and strategies. But before we move on, these are two key terms that I want to highlight to you, because I'm going to use these terms throughout my presentation. This term, learning tactic and learning strategies, is often used interchangeably, but then when we are doing research, we found that the literature is actually differentiates between these two terms. So learning tactic refers to a sequence of action the student perform to complete a given task for the ease of understanding and analyzing. We refer to a given task as one login. So one login, we assume that student have one task to complete. And then a sequence of actions. The similar patterns of sequence will be grouped as the similar learning tactics. Learning strategies is more broad term, which means that learning strategy refer to how students apply those tactics throughout the course. So the objective of this talk is we are focusing on the detection. Okay, so the highlight of the talk, the objective of the talk today is focusing on the detection approach. And then we are going to apply how we can detect the learning tactic and strategy across 3 different course design and delivery modalities. And then we are going to discuss this finding in terms of the theory, educational theory. Specifically, we're focusing on the approaches to learning. So what is approaches to learning? Approaches to learning is one of the well-known educational theory to explain how students direct their learning, how students approach their learning. So John Wick here identify 3 types of approaches to learning, which are deep learning, surface learning, strategic learning. 3 types. The first one, deep learner. Deep learner are those who aim to deeply understand the content. So they want to really understand the content and they want to achieve high score. So they know that the effort needs to be putting on in order to achieve the goal. And so they apply several tactics in order to achieve the goals. But surface learner are those opposite with the deep learner. Surface learner are those who I just want to pass the course. I don't want to put any effort. So I'm going to jump into those sections that I will be scored. So they just apply the shallow level of engagement just to pass the course. Strategic learner are those in between the deep and the surface learner. Strategic learner, similar to deep learner, they want to achieve high score, but then they understand in order to achieve high score, you need to put some effort. So they are being strategic in choosing what strategy, what tactic to use in order to achieve high score. These are 3 different approaches to learning that explained by the educational theory that we are going to look into. And another part is we are going to explore how the tactic and strategy are kind of associate with the task condition. What is task condition? It's actually another theory explained by Winnie and Hartwin. So Winnie is a professor at the Athabasca University. He is one of the professor who is expert in self-regulated learning. You might have heard of the term self-regulated learning. Self-regulated learning explains how one can direct their own learning. And Winnie explained this self-regulated learning process by using the information processing theory. And then it might be confusing from the look in the graph here, but then I'll just highlight the important things of my talk today is task condition. Task condition affect how students operate their learning, how students use the tactic and strategy. So what are task conditions? Task conditions are the constraint or the limitation you have in terms of time, resources, instructional cues, social context. So the easy way to say is that task condition is influenced by the use of how the course is designed and by how the course is delivered to the student. So task condition is how the course is designed and how it's delivered to the student. That is the main focus of the talk. So let's have a look into the study. In this study, we collect the data from 3 different courses. If you can see here, the name of the courses is Computer Engineering, Biology, Introduction to Python. If you look into the name, you knew that it's come from computer and also science, right? But then the nature of the subject itself is different. Computer engineering is more focusing on the computer in overall, also the hardware and also the software. So it's kind of introduction to everything about computer. But introduction to Python course is more specifically focusing on how to write program using Python. It's a language of programming, right? But biology course is kind of nature. The subject itself, the disciplinary is like a very pure science, right? So the design of the course itself also different. The design is different. Computer engineering was designed by focusing on the problem solving activities, which means students will have a series of problem solving exercise that they need to complete. And the course will offer based on the flipped classroom. What is flipped classroom? I think now you might have been familiar with the flipped classroom, but then I'm going to explain to you once more what I mean by flipped classroom. So flipped classroom, you will have face-to-face classroom. Face-to-face is where you will be participating in the traditional classroom. You will have to go to the class and see your lecturer and then participate in the class. This is face-to-face. But before, in the flipped classroom, this mode of delivery, before you are going to the flipped classroom, you need to get ready by participate in the online session. Participate in the online to prepare to get ready for the class. So the class will not be traditional lecture classroom anymore, but the class will be more active. There will be more activities, more discussion, more active learning to do. So you need to get ready by complete the online activities before going to the class. This is flipped classroom. So the concept of the topic, for instance, if you are learning about mathematics, the concept of this mathematics will be taught online, and in the class you will just focusing on the problem solving. That is the concept of flipped classroom. The biology course is different. In biology course, you need to go through the physical laboratories and then doing some work, some laboratories. So the design, we could say that the design of biology course focus more on the practical exercise, the practice-based exercise. You need to really practice and you need to do the laboratory in order to pass the course, right? So this biology course will offer based on the blended learning. Blended learning and flipped classroom is more or less the same, isn't it? Both of them have online activity and also face-to-face activities. But actually, they are slightly different. In blended learning, students are focusing on face-to-face classroom. They need to go to the classroom, but then they will offer with several learning materials online. So it's not necessary for them to get ready to complete everything online before going to the face-to-face classroom. They can go to the face-to-face classroom and then come back to review the online material as well. So the difference is that in flipped classroom, you need to complete online preparation, but in blended learning, you don't need to. But everything is provided to you online as well. And then, so the online activities in the online role of this biology course is to provide necessary learning materials and also to help the student prepare for the laboratories. The introduction to Python course is quite similar to computer engineering in the sense of course design. So the course were based on problem solving activities, but the course were often based on the modality of this introduction to Python course is based on MOOCs. MOOC is massive open online learning online courses, which means that it's completely 100% online. There is no face-to-face. You can stay as far as half of the world to participate in this introduction to Python course. In fact, this introduction to Python course were offered by the university in Chile. So many students can participate in the course from different countries. So these are three courses, three datasets that we are using in this study. So there are two different designs. Two of them focusing on problem solving activities. One biology course focus on practice-based activities. And three different modalities. One which are flipped classroom, blended learning, and MOOCs. These are three different courses. So let's have a look into the data. This is how the activities were arranged for the student. In computer engineering, the first column, computer engineering course. So in this course, the course were designed by providing with the video lecture, reading material, the one that I highlighted in blue. So they have conceptual quizzes, they have practical exercise, or they have problem solving exercise. Okay, this one refer to problem solving exercise. But then the main focus of the student were on problem solving exercise. They also watch the video, they also read the material, they also doing some quizzes. Okay, this is the what the course provide to the student. In biology course, the lecturer provide the student with a lot of reading material. They will also have quite active discussion forum, and there were lots of update at the homepage, update news and all those stuff. And then student will have pre-laboratory activities to complete. And then in Python course, the lecturer provide with lecture video and also quizzes, as well as the practical or problem solving exercise. But look into the number. Student mainly focus, and also lecturer provide a lot of these practical exercise, problem solving activity, 80% of all the data sets. Okay. So I've been talking about trace data, about digital footprint of the student, about the data we collect. How does it really look like? It looks something like this. If you look into the log data or the trace data, or you may call digital footprint data, you might find something like this, which in the eyes of a person, you might not be able to understand what does it mean, right? But actually there are some pattern in this. So the first 4-digit number is student's ID, and then after that you have a timestamp, what time the student interact with the system, and then you have a activity that student are focusing on, the student click on is exercise activity, and then you have a link that student interact with, which you can extract the learning topic from this link. And also you have an action of the student, the action that the student perform. This is how the data look like. But by using the traditional method, it will be very difficult to grab this, to understand this data, this trace data or log data or digital footprint data, isn't it? So that's when learning analytics come into play. That's why we apply this type of methods. It might sound a little bit technical, just bear with me. I'll try my best to explain what it is. So in this study, as I told you earlier, we are focusing on to detect the students' learning tactic and strategy, and tactic refer to a sequence of the students' learning actions in one session. So we have here a session. In each sections, student will perform different action. A is action. For example, when I log in, then I go to home page. It might be my A1. My action one is going to home page. My action two might be going to the video to watch the video, and my action three might be I click play video and I pause the video. This is might be one session, but in session two, I don't feel like watching video anymore because I have already watched it. So my session two might be I begin by going to the homepage and then I jump to the exercise because I already watched the video. So in different sessions, students will have different sequences of learning actions. So based on the patterns of these actions, we apply the first order Markov model and also apply expectation maximization. These two are the machine learning algorithm, you can say. So what these two do to the trace data, they kind of formulate the process of students learning and then try to categorize or group the patterns of learning sequences. So the same learning sequence will be grouped in the same group. For example, these sequences in tactic 1 is quite similar, so it might be grouped into one tactic. And these two at the bottom is look more or less the same sequence, so it will be grouped into tactic 2. When we are doing this, it's come into align with our definition that have been given by member, that the learning tactic refer to a sequence of learning actions students perform. So strategies, theory has been defined strategy as how student using the tactics. So how each student using tactics, right? So we apply, transform, we normalize the data, and then we apply Euclidean method and apply hierarchical clustering algorithm, another data science, another machine learning algorithm we apply to this data set, and then it enable to detect the patterns of how students using the tactic, and we call this as strategy groups. So similar patterns of using the tactic will be grouped into similar strategies. This is the general idea of our method to detect the tactic and strategies. So how it look like when we apply, how the process does look like. So we got a trace data, we code the data into the category, the student, the time, the activity, the topic, and then we apply the form, the first order Markov model, and then we got something like this. Is not understandable. And then we apply clustering technique by using the expectation maximization algorithm and come up with something like this. So it grouped the same thing together, the same pattern together, and we can explore it further, how the sequence is actually look like. And then we call these as a tactics, right? These are the tactics. And then how each student using the tactic is a strategy. So we apply another clustering and identify the behavior of using the tactics. This is the tactic that students use. And then we also explore in terms of the process mining as well. So these are the process of how we do the learning analytics, how we try to understand students' behavior from the trace data. So what did we get? So we in computer engineering, remember, is based on problem solving design, but the course more like they have several activity involve the exercise. They provide the video lecture. They also provide reading material. They also provide with quizzes, right? So we got 5 different learning tactics. We got diverse tactic is consists of 12% of all learning section that we use in this study. We got reading oriented. Why? Okay. We got diverse. Sorry. We got diverse. Diverse mean that many, right? So diverse mean that student apply many learning actions. So it's just everything in one section, one sections. Reading oriented, 26% of all learning student participate in reading. What is reading mean? Reading oriented mean student focus on reading material. So a lot of behavior, the dominant one is reading. Exercise, 25% of all learning session, but student focusing on the problem solving activity. Similar to MCQ. MCQ stands for multiple choice quizzes. So 80% of all learning session that student access to reading material and they follow by MCQ question. And video oriented student was just focusing on the video lecture. So how it looked like, it looks something like this. The color represent the behavior. I code it down here. So the purple color, lots of purple color over here refer to different action related to video. The green, the red one refer to the MCQ, different type of action that student doing when participate in the MCQ, interact with the MCQ. The green one is refer to problem solving exercise, EXE exercise. So two different type of action. They are doing exercise correctly or they are doing exercise incorrectly. So these are the tactics we found from the computer engineering course. Let's have a look into biology course. Biology course, remember, 44% of the learning activity were reading material. They provide a lot of reading material. So the course were designed based on practical base. Students need to go to the laboratory. They need to prepare for the lab. And it's what offered based on the blended learning. We found 3 different behavior of reading oriented. So students just focusing on reading, 44% of the learning session, and 17% focusing on reading and also prepare for the lab. Another one is reading and participate in the discussion forum. So the cluster looks something like this. One is just yellow, another one is yellow together with the red one, another one yellow together with the blue one, and the code name is somewhere here. And the introduction to Python course, remember, is based on problem solving. 88% of the data were participate in the problem solving based exercise, and it's offered based on MOOCs. So we got a different type of exercise. We got diverse practice, short practice, long practice, and we got one type of tactic when students just focusing on the video lecture. It's a very short learning session. So the cluster, the tactic, the number of distributed tactic looks something like this. So most of them are focusing on the exercise. Remember, I told you the green one are exercise. So just different behavior of exercise. So what can we say from this result? I have already shown you this number, right? So this one, I highlight the activities that the lecturer provide to the student. Like video lecture, quite a lot in computer engineering, reading material, quite a number, and then quizzes, and then practical exercise. But in biology course, lots of reading material provided to the student, pre-lab activities, and discussion and update. And this one, practical exercise, we're just focusing on the Python course. So the same one, let's have a look into our detected tactics. Yeah, we found this. We found for the computer engineering, which were offered based on the problem solving activities on the flipped classroom, we found different learning activity corresponding to the course design, corresponding to how the course were designed. Similar to the biology course, when they provide a lot of reading material. So we have the corresponding tactics to the course design, but then again, some of them are combined together with another activities. Similar to the Python course, the course were designed to focus more on the exercise, the practical exercise. And then we have 3 different behavior of exercise and 1 tactics focusing on the video lecture. Okay. So we can say that the tactics kind of reflective of how the course were designed, isn't it? So let's have a look into the another result when we detect the patterns of the tactic, how students use these tactics. So in different courses, we have 3 different type of patterns. It might be difficult to look now. Let me highlight to you what's important. So the first behavior we detect, the first strategy we detect from across 3 different courses, we detect this pattern of intensive high engagement. High engagement indicate that they are quite active. They apply several of tactics. For example, in computer engineering course, they have 5 tactics over here. They have 5 tactics. And then students who behave as intensive high engagement learner, they apply several tactics. So most of the tactics were used once in a week, at least. At the beginning, they focus on the golden color here. They're focusing on reading, behavior, and also they focus on exercise, a lot of them, and they watch video at least once in a week or twice. So they know that learning needs some efforts, right? So they aim to fully understand the content. The biology course, have a look. They apply several of these 2 behavior, reading oriented and reading and discussion. So a lot of tactics were used. And reading and pre-lab, have a look. One more thing I forget to mention to you. The pre-lab will be during this week, from week 4 to week 6, and then during this week at the end of semester. And students will usually have a midterm test during week 7. Similar here, students have midterm test during week 7, and also exam during week 13. So when it comes to this group of students, they will just constantly apply a high level of engagement. They apply all of the learning. They interact with all of the learning activities and apply the several learning tactics. Similar to high activity from the MOOCs course, from Python course, they apply several of the learning tactics. These are one pattern that we detect. It's kind of explainable in terms of the deep learning approach, which means that students are being highly engaged. They put a lot of effort to understand the contents, and they aim to fully understand the contents and to achieve high score. So they apply diverse learning actions. When you look into the second group that we detect from these courses, this is from computer engineering course, we detect this pattern, and also from biology course, we detect this kind of patterns, which is quite similar for both. They are the number of engagement are much lower from the first group. First group is quite high, but this group is a little bit lower, and they are being more strategic. What I mean by being more strategic, have a look into what type of tactic they use. At the beginning, they use reading tactics. They use reading tactic, but then when it comes to but then it dropped. And when they drop the reading tactics, they're focusing more on the video watching. So they either read or watch the video. So they are being strategic on what type of the tactic they should use. And also for this exercise, they know that exercise contribute to the understanding, so they focus more on the exercise. They focus more to apply the knowledge. So these students know how to study. They are being strategic. They put they want to achieve high, but then they put shortcuts to complete the course, right? Isn't it? Okay. These are strategic group, similar to the strategic moderate engagement detected from the biology course. The level of engagement is moderate as compared to the first group and the next group. So they apply several tactics available for them, but then they are being strategic. Why? Because during week 7 they have midterm tests, and look at the number of tactics used during that time. It's kind of peak, isn't it? Especially for reading and discussion, reading and pre-lab oriented. Reading oriented. So during this time, they will look back into the reading material, and then they will start asking questions in the forum on the things that they don't understand in order to prepare for the classroom, for the exam. Similar to at the end of the exam, week 13 when they have the exam. They participate more on the forum. They read and then participate in the forum, asking questions on something they don't understand, or have a look into the question their friend asks. And the reading and pre-lab activities, here you can see from week 4 to week 6 and also week 7 to this week, they only doing the pre-lab oriented when they have the laboratories. When they don't have, they just ignore it. So they are being strategic on what type of tactics they are going to use. It's kind of representative of strategic learning approach by weeks, right? So let's have a look in another patterns of strategies. These patterns, if you compare with the first two groups, these patterns has a very shallow level of engagement. They have a low engagement or either be inactive at all. And they just apply one or two tactics available for them. For example, they know that, okay, exercise is important. So they just do exercise once in a week. And at the beginning, they are quite active, focusing on reading material. But then after the mid-semester, they just ignore it. So they have a very low level of engagement, highly selective on what tactic they use. Similar to this high selective, low engagement from biology course, they apply several at the beginning and then they drop during the week, along the week. And again, they get back to it because I have to prepare for the test, for the exam. Similar here. But then the level of engagement is just shallow. This one here also, the level of engagement was just shallow. So it's kind of representative of Vic's idea on surface learning approach. And another pattern we detect is from Python course, students were being highly active at the beginning, and then they drop, the level of engagement would drop. And have a look into what type of tactic they use. They use the green one representative of lecture-based oriented. Remember, lecture, there is no exercise at all. So these students are focusing on lecture-based on a Python course. Python course is designed based on the problem solving. You need to code, you need to doing different kind of coding, but then students are using the lecture-based. So there are something over here. And then when we explore in terms of academic performance, of course, these strategic and intensive group score very well, and the highly selective low engagement score the lowest among the three, and high active at the beginning score low and inactive score low. These strategies associate with the low performance. And when we look into in terms of statistics, we found significant difference in terms of this group. So we can confirm that the The high intensive, high engagement were more associated with high performance, and the low engagement is more associated with the low score, low performance. Okay, let's just have a summarize. In terms of deep learning approach, we detect this deep learning approach for intensive high engagement strategy group from the computer engineering biology course and also in Python course. Surface learning, we detect for the group name highly selective low engagement from computer engineering biology and Python course. Strategic learner, strategic detected from strategic moderate engagement from computer engineering and biology course only, but the moving toward from deep to surface are from Python course. So we can say that the flipped classroom, the course that were delivery both by combine both face-to-face and online learning have a similar strategy that students use, but the complete online is kind of different. This is our finding by using the same method to detect the strategy, tactic and strategy. So to summarize, in this study, we examine the use of we call process analytic method to across 3 different course design and delivery modality, and we examine in terms of theory. What we found that learning tactics are reflective of how the course were designed. The actions are more associated with how the course were designed. The learning strategy was sensitive to the delivery modality or the mode of delivery. So why are we concerned about this? Because if we able to detect those students who need help in time, just as those who tend to apply surface learning approach, or those who inactive, or those who are highly active at the beginning and tends to drop after a course progress, these students they need help. So if we can detect those students in time, we can somehow provide them with the feedback and maybe motivate them to continue working, or maybe give some more guidance, some more tutorial to help them when they struggle to understand the contents. This is the aim of why we concern to understand students' learning behavior. So it comes to an end of my talk. Please, thank you very much for your attention, and please feel free to ask if you have any question.
Thank you so much, Dr. Vanessa, for addressing this interesting topic and giving such interesting presentation. Ladies and gentlemen, now we come to the question and answer session. If you wish to ask question, you can simply type your question into the chat box and I will read it out loud. Okay, Dr. Vanessa, I think I have one question with me here. This is very simple question. The question sounds like this. If I want to start doing the learning analytic research, where should I start and what should I look into?
Very well. I think the first thing to start is by formulating the question. So what are your interests in understanding students' learning? It can be, well, there are several ideas of using learning analytics to understand students. They can be predictive. You can try to find out whether you can predict student learning grade, or you can explore students' learning behavior like I did. You can even explore students' motivation. You can use it together. You can use the trace data together with the questionnaire as well. These are some of the interesting topics so far, in my opinion, anyway. But then I would say the starting point would be have a look into the research, have a look into the meta review research or learning analytic that will save your time. Actually, me and Aryu also doing some literature review, systematic literature
Okay.
review or learning analytic dashboard. If you interest, you can ask for more information from Dr. Nora Aryu here. And there are several of learning analytic systematic literature review. So they kind of summarize for you what learning analytic has been used and how it can be used, what kind of methods that are currently applied in learning analytic. And I would say another things to do for to head into learning analytic field is try to have a look into the data science techniques. It's not really need to be, you don't need to be technical in order to apply data science, because currently there are many tools available that you can just click upload your data and then come up with the result. For example, the work done by David Schaffer from University of Wisconsin Medicine, they come up
Yes.
with a tool, web tool to produce the social network analysis. They call it epistemic network analysis, or ENA web tools. You can search from this from Google, and their tools allow you to well, you need to kind of formulate your own data set first, and then you can just upload the data set into the web tool, and then it will produce you with the network of connection. But in order to use that, you must understand what you want from your data set first. Another
Yeah.
web tool that you may try is called Jar Movie. It's more or less like SPSS type, right? But then you can upload your data set and then have, there are several functions on what you can do. Those are the two for the, I think, if you want to begin with.
Yeah, thank you, Dr. Vanessa. Well, ladies and gentlemen, I think now we already have several questions here. And the first question is just now that have been answered by Dr. Vanessa. And the next one is, Dr. Vanessa, how do you ensure the reliability and validity of traces data?
Yeah, this is very interesting question. If you work with data, you will see that the very first step of working with data is important. It's called cleaning data.
Yeah.
So you need to ensure that the data you have is kind of what you want. So you have, when you clean your data set first, you need to understand the context. So usually when we clean, when we analyze the data, any data set, we just involve the owner of the data, the owner of the course, the owner of, yeah, the instructor of the course, because they are better in understanding what is going on in the class, right?
Yeah.
So in dataset from, for example, computer engineering, the course will offer in University of Monash. So we involve the professor who designed the course, and then yeah, most of, I would say every dataset we involve the owner of the course. So when we analyze and when we have the initial finding, we discuss with the owner of the course. So when we discuss with them, they will point out what is missing or what is strange here, or this is correct, something like that. And usually when we use the data science method, it will show you if you have a missing parameter or something like that. So that is one of the steps to clean the data, to ensure that your data is validated.
Okay. Great. Thank you, Dr. Vanessa, for that very brilliant answer. So maybe we can move to next question. This is based on your study just now that you presented. Based on your research just now, does the trend shows that technical courses which apply in MOOC are not effective?
Very well. That is based on, I need to remind you that the analysis is based solely on the trace data. There are many factors that affect on students when they participate in the MOOCs course. Let's say it this way. When we participate in the credit course, we have some sort of pressure because you need to pass the course in order to graduate, isn't it? You have a little bit of slight pressure here. But then if you participate in the MOOCs course, usually you just want to learn some knowledge, right? You are freely to drop out anytime you want. There is no pressure in here. And those who participate in the MOOCs course are usually, I'm not saying that they are not student, but some of them are student, some of them are apply in order to just to recap, to review my understanding on particular topics. I don't want to just complete all the course. No, I just want to review this topic. And some of them will just apply in order to examine how the course is going. Some of them really want to learn. So the behavior, the intention, the motivation to complete the course are different. So we cannot say that the MOOCs course is not good, but actually we have to study more on the students' intention, students' goal of learning, students' motivation, and also time management is one of the interesting research question when participate in the online learning. So I would say there are many factors affect on students' performance, not just the course design.
Yeah, exactly. I also agree with you. Okay, we come to our last question. Dr. Vanessa, instead of learning analytics, can we do teaching analytics as well?
Yeah, actually, that's interesting. One of our collaborator from Finland, he's focusing on teaching how the teacher teach learning analytic, teaching analytic or something like that. But then the work is still going on, and actually that is very brilliant idea. I like it. Uh, yeah, why don't we focusing on teaching analytic? Is so far, I would say there are only a few research in this, and yeah, I totally agree with you.
Okay, thank you, Dr. Vanessa.
Thank
Thank you
you.
for answering those questions. Great, thank you, everyone. Finally, we come to the end of our webinar. I would like to say thank you again to Dr. Vanessa for the informative and interesting talk. And thank you, everyone, for attending today's webinar. Hopefully, the input will be beneficial to everyone. Before you leave, make sure you have filled in the attendance form that available in the chat box. On behalf
And
of the
thank you for
Faculty of
having me too.
Information Management and our presenter, thank you for joining us today and have a great rest of your day. Thank you. Assalamualaikum. Bye.
Thank you. Bye bye.